in the diagram, the length of AD is equal to the length of BC. So AD is equal to BC. So we've got these two little lines which represent equal length. The angle ADC, so ADC, so this angle here, is equal to the angle BCD. So BCD, so this angle here. Prove that the length of AC is equal to the length of BD. So the length of AC from here to here is equal to the length of BD from here to here. So if we consider the triangle ACD, so ACD, if we consider this triangle, which we get from here, ACD, and the triangle BCD, BCD, which we get from here, BCD. So we're going to draw them out separately. That's the best thing to do. The length of AD is equal to the length of BC. That was already given to us. So AD is equal to BC. So AD is equal to BC. That was already given. The angle ADC, so ADC, so this angle here, is equal to the angle BCD. BCD, so this angle here. Again, that was already given to us. This angle is equal to this angle. DC is a common side. So DC is at the bottom here. So here's DC on the triangle on the left and DC on the triangle on the right. Remember, if we were to stick these two together, they would form this shape. We would just have to put a line along the top to finish it off. So we have a common side DC. So DC is obviously equal to DC, so that's why we have two little lines, which represents that those two lines are the same length. So DC is equal to DC. So thus, the two triangles are congruent. So congruent means identical. So if we have two triangles that are congruent or identical, it means three equal sides, three equal angles. They're the exact same. So they may be, one may be a rotation of the other, one may be a reflection of the other, or one may be a translation of the other. But when we learn about similar triangles, they're different to congruent triangles. Similar triangles have all the angles the same, but the side lengths are different. But the side lengths will always be in the same ratio. So one triangle may be an enlargement of the other. So the angles all being the same, but the length's different, but the lengths are in the same ratio. So these two triangles are congruent. It means they're identical. The three angles are the same and the three sides are the same. And we know this because of SAS. SAS stands for side, included angle, side. So we have a side, an included angle, an in-between angle, and a side, an included angle or an in-between angle, and a side. So that's all the information we need. We know that automatically everything else is the same as well. So congruency can be found with SAS, so side, angle, side, ASA, angle, side, angle, SSS, side, 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 and RHS, right angle, hypotenuse, and another side. So since these two triangles are congruent, hence AC is equal to BD. Because we know all the other angles and sides are the same, so they must be equal. So AC is equal to BD. Now when we looked at this shape straight away, we didn't see triangles, but that's why we need to draw into our diagram, or else draw extra diagrams to help us. Part 2, we need to prove that the angle DAC, so DAC, so this angle up here, which we could label now as Z, is equal to the angle DBC. So DBC, so this angle up here, which is also labelled as Z. So since we know the two triangles are congruent, we also automatically know that these angles are equal. So the angle DAC is equal to the angle DBC, which is equal to the angle Z. So part 3, we have to prove that AB, so AB is parallel to DC. DC. So I've drawn in these two little arrows which represent parallel lines, and we have to explain our reasoning. So from above, So from the sketch we drew in the previous question, which was the triangle ADC and BCD, we know that the angle DCA, so DCA, so this angle here labelled as X, is equal to the angle BDC, so BDC, we've also labelled as X, which is equal to angle X. So we know this because these two triangles are congruent, so all the angles on all the sides are equal. All the corresponding angles and corresponding sides are equal. Okay, so now consider the triangles ABC, so ABC, so ABC, and the triangles ABD, so ABD, so ABD. So again, I've drawn them out separately and pulled them apart, but if we were to stick these two together, it would form the same shape. So AB is common to both, the side AB, so it's basically the top of our trapezium. So that's why we have three little lines either side, so they're definitely equal. BC is equal to AD, so BC is equal to AD, so BC is equal to AD, that was already given to us. And we've got one little line to show that. And AC is equal to BD, so AC is equal to BD, so AC is equal to BD. So we got that in part 1. Thus, the triangles are congruent by SSS, which represents side, side, side. So we have 3 equal sides. So here's the triangle again from the previous slide, ABC, and the triangle ABD. So we know that the two triangles are congruent, so they're identical. 3 equal sides and 3 equal angles because of SSS. So the side BC is equal to the side AD, it's got one little line. The side AC is equal to the side DB, it's got 2 little lines. And the side AB is equal to the side AB, it's got 3 little lines. So since the 3 sides are equal, they have to be congruent. So therefore the angles are all the same as well. So the angle CAB, so CAB, which is labelled as W, is equal to this angle DBA, so DBA, which is also labelled as W, which is equal to angle W. So we've matched up those angles. The angle ACB, which we've labelled as Y, is equal to the angle ADB, which we've also labelled as Y, which is equal to angle Y. Putting it all together for the triangle ADC. So ADC. If we have a look at it down here, ADC. So this triangle here, ADC. So 2 times angle X plus Y plus angle Z is equal to 180 degrees. So if we look at ADC, we have angle X plus angle Y plus angle Z makes up a triangle, which is equal to 180 degrees. So remember there's 2 of angle X down the bottom here. So angle X plus angle Y plus angle Z equals a triangle, which equals 180 degrees. And then for the triangle ABC, so ABC, which we can have a look at here, ABC. So again, this is a triangle. So we have 2 of angle W plus angle Y plus angle Z is also equal to 180 degrees. So we've got angle W plus angle Y plus angle Z forms a triangle. So those angles added together should give us 180 degrees. So then adding them all together, we've got 2 of angle X plus 2 of angle Y. So we've got angle Y and angle Y plus 2 of angle Z and angle Z, plus 2 of angle W, And that's all going to give us 360 degrees, because 180 plus 180 is 360. So, dividing across by 2, we get angle X plus angle Y plus angle Z plus angle W is all equal to 180 degrees. So angle ADC, we can see is actually X and Y put together. So angle X plus angle Y gives us angle ADC. and then angle DAB, so DAB, we can see is actually angle Z and angle W put together. So angle DAB is angle Z plus angle W. So if angle X plus angle Y plus angle Z plus angle W is equal to 180 degrees, then angle ADC plus angle DAB is equal to 180 degrees. So we have angle ADC, so this angle here, plus angle DAB, so this angle here. So these two angles together, added together, gives 180 degrees. And as adjacent angles sum or add to 180 degrees, the line AB must be parallel to TC. So another word for adjacent angles is supplementary angles. So when we have two parallel lines and a transversal cutting between them, or cutting through them, then these two angles here, so this angle here and this angle here, make supplementary angles, so they would add to 180 degrees. And likewise this angle here and this angle here would also make 180 degrees. They're also called co-interior angles. So they can be called adjacent angles, supplementary angles, or co-interior angles. Either way, they add to 180 degrees. So likewise on the other side, this angle and this angle would add to make 180 degrees, which proves that AB is parallel to DC.